Assalamu alaikum guys, welcome back. Okay, so now in this previous video we completed the definitions of redox reaction, oxidation and reduction, and all the 4 definitions. Now in this video we're going to talk about the rules for assigning oxidation numbers. Alright, so in the previous video I gave you one definition in terms of oxidation numbers, right, in which I told you that gain in oxidation number is oxidation and the decrease in oxidation number is reduction. Now in order to calculate the gain or fall or decrease in the oxidation number, you actually have to know how to assign oxidation numbers to different compounds or different elements or most of the elements in the syllabus. So let's get started. Alright, so basically first of all, the first rule that you must remember that group 1 and group 2 elements in our syllabus, all of them have the charges or their oxidation states equal to their charges. Okay, for instance, sodium, when it loses one electron, it gains a charge of +1, right? So +1 is a charge, it's a fixed charge, it doesn't change for sodium. Similarly, in case of magnesium, which is a group 2 metal, it loses 2 electrons to gain a charge of +2. So +2 is the oxidation number of magnesium and it stays constant, it does not change to +3 or +4 or +5. Okay, the first rule that you must remember. So oxidation numbers of group 1 is going to be +1 and for group 2 it's going to be +2, and that's it. Then the second rule that you must remember is for oxygen. Oxygen atom that you have, right, the oxygen has a fixed oxidation number of -2. -2 is a fixed oxidation number of oxygen, but there are exceptions to this rule. Only if oxygen is present in the form of superoxide or in the form of peroxides, it won't have an oxidation number of -2, it will have different oxidation numbers. Okay, superoxides mean O2 2- and peroxide means H2O2, right? Yeah, superoxide and peroxide. So only in these cases the oxidation numbers of oxygen are going to be different, whereas in case of all the other places, the oxygen will have oxidation state of -2. Then coming to halogen. Halogens, they commonly have an oxidation state of -1, but they have a large range of numbers. They can be from -1 they can go to +1, or they can also go to +2 or +3 or +4 or +5, +6 and +7. Okay, I personally saw a question on the past papers in which the examiner asked to give all the possible oxidation numbers of chlorine. Okay, so the answer actually went from -1 to +7 in case of chlorine. So halogens, they generally have a wide range of oxidation numbers which you actually have to calculate, and if no information is given, then of course you have to take them as -1, but generally you do get some idea in the question regarding halogens. Then coming to the fourth rule, which says that in case of ions, if you have ions, right, in case of ionic compounds or ions, oxidation state is always going to be equal to the charge of the ion. For instance, if you've got let's say you've got this ion over here, sulfate, SO4 2 negative, so the overall oxidation number is -2. In case of nitrate, NO3 minus, the overall oxidation number is -1. In case of potassium, K positive, the oxidation number is +1. See? So this is how you assign the oxidation number for ions. Okay, now in case of elements in their standard states or in their elemental form, the oxidation number is always going to be 0. Okay, for example, you have the same oxygen, but you don't have oxygen atoms, rather you have oxygen gas. Oxygen is a gas at room temperature and pressure, right? This oxygen gas will not have an oxidation number of -2, rather it will have an oxidation number equal to 0. Okay, O2 will have an oxidation number equal to 0. And sodium, metal, in the metallic form will have an oxidation number equal to 0. Hydrogen will also have an oxidation number equal to 0 in the elemental form. Nitrogen and so on, any element which you find will have an oxidation number equal to 0, or even if you find any compound, for example, carbon dioxide is a compound, the overall oxidation number of carbon dioxide is also 0. For example, you find a compound, let's say sodium chloride, the overall oxidation number is still 0. I'm not talking about the individual oxidation numbers, but rather the overall. Overall, how to calculate the overall oxidation number? Overall oxidation number is actually the sum of the individual oxidation numbers that you have. Okay, for example, you've got sodium over here and chloride over here. Sodium has a charge of +1 because it's an ionic compound, so it is an ion, not a solid atom. Okay, it's not atomic sodium, it's ionic sodium, so has a charge of +1, whereas chloride has a charge of -1. Right? Chloride is chloride, it has gained only 1 electron, so it's -1. The overall oxidation number of sodium chloride is going to be +1 added to -1. +1 for sodium added to -1 for chloride, and +1 -1 is actually 0, right? So the overall oxidation number is 0. Even if you have compounds, neutral compounds, their oxidation number is going to be 0. Now coming to a few examples in order to better explain all these rules. Okay, so the first example is given to you right over here. Hydrochloric acid reacting with sodium hydroxide forming sodium chloride and water. Remember, this was an example of neutralization reaction. Okay, in this case, if I take HCl, okay, and by the way, this is aqueous, this is also aqueous, this is aqueous, and this is a liquid. Now, in case of HCl, what's going to be the oxidation number of hydrogen? It's a proton, right? It's HCl, so it's going to be +1, and for chloride, it's going to be -1. In case of sodium, it's going to again be +1. In case of OH entirely is an ion, right? OH negative is an ion. It has an oxidation number of -1 again. Now over here as well, sodium has a charge of +1 and chloride -1, and water is actually a neutral compound, so it's gonna have a charge of either 0, or you could assume it to be this way. You've got 2 hydrogen atoms over here, right? 2 hydrogen atoms are there. Each hydrogen atom has a charge of +1. But since there are 2 hydrogen atoms, you are going to multiply it by 2. And oxygen, since it's not an element oxygen, rather it's in a bonded form, so it will also have a charge of -2. So +2 and -2. Okay, so now these are all the charges. So if you look at, anyways, but water, since it's an elemental form or it's a compound, so overall charge is going to be 0. Okay, even for sodium chloride, the overall charge is going to be 0. But this is how you identify the charges, okay, plus and minus. Now guys, the main thing isn't identification. I just want you guys to tell me whether this is an oxidation reaction or a reduction reaction or neither of them. Well, if you look at the hydrogen over here, has a charge of +1. From +1, it remains +1, right? It's still +1 in there. Even if it is in the water form, it is still +1. Hydrogen has a charge of +1. So if hydrogen has a charge of +1, that means there is no change in oxidation number. It was +1 and it remains +1. If you look at the OH negative, this hydrogen over here is still +1, okay? The OH negative hydrogen is also +1. This is +1. Why is there an overall minus sign? Because oxygen has a charge of -2, hydrogen has a charge of +1, so -2 + 1 is -1, so that's why it's OH negative, okay? But hydrogen still is +1, right? So +1 to +1 there is no change. Similarly, chloride also remains -1, sodium also remains +1, so there is no change at all in the oxidation numbers going from left to right. So therefore we cannot say that either oxidation or reduction has occurred. The answer is going to be not redox. This reaction is not redox. Neither oxidation nor reduction has occurred over here, okay? After this, if you look at the second example over here, in the second example, we need to calculate the oxidation number of manganese. Okay, manganese. Potassium manganate has been given to you. Okay, for such examples, this is a very important question because you've got tons of MCQs testing for the oxidation number. So now let's look at them. Potassium is a group 1 metal, right? It's a group 1 metal. So group 1 metals have a charge of +1. So I'm going to write down the +1 over here. And there is just one potassium atom, so I don't need to put brackets or multiply it with some other number. I'm going to add this to the charge of manganese, but I don't know the charge of manganese, right? I'm going to assume it to be X, okay? And then I'm going to add that to the charge of 4 atoms of oxygen. You've got each atom of oxygen has a charge of -2, right? I told you in the beginning that oxygen will have a charge of -2 if it's not in the elemental form or if it is not in the form of peroxide or superoxide. And how many oxygen atoms do we have? We've got 4 oxygen atoms, so you are going to multiply this -2 by 4 as well. Okay, now you've gotten a linear form, you've got a bunch of numbers. You are going to equate this bunch of numbers. Now these numbers will actually, when they are added together, will give you the overall oxidation number. Okay, but potassium manganate is actually a compound. It's a neutral compound. It's an oxidizing agent. Remember, it's a neutral compound. If it is a neutral compound, what's going to be the overall oxidation number? It's going to be, in case of compounds, it's going to be 0. So you are going to equate this equation to 0. Now once it is equated to 0, all you need to do is just apply your math and get the value for x. 4 times 2 is -8, plus 1 is going to be -7. So x is going to equal to +7. So +7 is the oxidation number of manganese in this equation. This is how you calculate the oxidation number of unknown compounds. Similarly, you can try the same stuff over here in case of potassium dichromate to find out the oxidation number of chromium. What's the oxidation number of chromium? Okay, I'm not doing this. I'll just give you the direct answer to this. The answer to this is +6. Okay, so calculate it and get your answer. Otherwise, I'll just do it. Okay, don't worry, I'll do it. 2 atoms of potassium. You've got 2 atoms of potassium. Okay, what's the charge of each atom? It's going to be +1. You've got 2 atoms of chromium. What's the charge of chromium? We don't know, right? It's unknown. So just put a Y over there or an X over there. And then you've got 7 atoms of oxygen. And you're going to equate that to 0 as well, because the potassium dichromate is also a neutral compound. So 7 times 2 is -14. -14 plus 2 is -12. -12 goes there. So 2y equals +12 and y is equals to +6 is your answer. Okay. Similarly, you can calculate the oxidation number of sulfur in case of sulfate. Now this is different from dichromate or manganate. Reason? Because this is a charged ion and the overall oxidation number is -2. Same applies for nitrate. The overall oxidation number is -1. So now when you will be calculating the oxidation number of sulfur, let's assume it's to be X. Okay, when X is added to 4 atoms of oxygen, each atom of oxygen has a charge of -2. So you're going to multiply the 4 by -2 and equate it not to 0 this time. You're going to equate it to -2 because its overall charge is -2. Okay, it's the overall charge that we are supposed to equate it to. So this is 4 times 2 is -8. It will go there, become +8. 8 minus 2 is plus 4 times 2 is -8 plus 6. Okay, +6 is the charge of sulfur in case of sulfate. Now coming to nitrogen, apply it, do it yourself. I'll just do it verbally with you guys. Let's assume it to be y. So y plus 3 times -2 is -6. So y plus -6 equals -1. -6 will go there, become +6. 6 minus 1 is +5. So y has a charge of +5 in this case. Okay, so this is how you calculate the oxidation number of individual atoms, individual ions, and this is how you identify the oxidation number in reactants and products, and you can compare and contrast to see if it is a redox reaction or not. Okay, so that's it guys. This completes the discussion on redox reactions. Thank you so much.